Hello, we will be here. My name is Johan Balseiro, and I will be presenting my author classification algorithm using the KNN nearest neighbor algorithm. Alright, so first things first, the motivation for this project is to solve the problem of authorship attribution, which is going to be rather significant in the next coming years with new text processing and AI generated text, which involves usually identifying the author of a given text based on writing style, which is a lot more effective than simple string matching. This task is crucial in many areas, including literary studies and even more in plagiarism detection, since style it's harder to escape than, say, it's easier to keep track of than pure string, just literal string matching, since users can simply just use newly generated tests instead of plagiarize. But with style detection, you can find that as well. Previous approaches to this problem have included statistical analysis and linguistic features. Usually, they were made to catch spam, which it's not really effective in the case of this implementation. But it was most of the uses for this type of model are for spam detection. Also, I was personally curious on style detection since I felt like I personally was fairly decent at figuring out which author I was reading, even if I had no way of determining what type of book it was, or if I couldn't detect the specific author, I could probably detect the origin of the book. But I was wondering how effective a model would be at this rather than compared to a regular human. And it turns out it's much better. But I guess that's predictable. Next things first. Next thing is the goal. According to instructions, we have to speak of the input as well as the data we used. The input for the system is a corpus of text called the Gutenberg corpus. They're most likely much better data sets than this, but this is a fairly small one, and it works fine for my purposes. It's a collection of texts for different authors. The texts are obviously they're classified with the name of the author that they're related to, so this falls under supervised learning. The output is the predicted author for a given text, of course. The data used in the system is taken from the Gutenberg corpus previously mentioned, and includes the author, title, and text of various works. Obviously, this is a classification problem, with each author representing a different class. As for the implementation of the KNN algorithm, I use Python's scikit-learn library, which, to be completely honest, I got from a GitHub repository. That was it had fairly liberal use of it. Every time I see a KNN algorithm, they use a scikit-learn library. Data preprocessing involves rereading the text files, removing stop words, and converting the text into numerical data using the count vectorizer and tdiff transformer classes. This is fairly standard stuff for data preprocessing using Python classes, and it is absolutely needed when trying to classify text. The data is then normalized using the min-max scalar class. Performance is measured using accuracy, precision, recall, and F1 score, as we do. As for experimental results, the system achieved an average cross-validation accuracy of 0.455 and a test accuracy of 0.529. Precision, recall, and F1 score were around 0.53. Oh, sorry, 0.59. That's incorrect there. The model's running time was reasonable, taking only a few minutes to train and predict. The performance of the system is moderate, but could be improved with further optimization, of course. Personally, I'm thinking that it could be the SVM algorithm, since I see a lot of the previous works were using that algorithm instead of the KNN algorithm. Okay, so compared to previous work in authorship attribution, the system performs moderately well, but definitely has room for improvement. The main contribution of this project is the implementation of a KNN algorithm using the scikit-learn and the use of a large dataset from the Gutenberg corpus. I didn't really find many KNN algorithm implementations of author attribution, so I guess this is rather novel. Future work could include incorporating more advanced feature extraction techniques, optimizing the KNN algorithm's hyperparameters, and exploring other machine learning algorithms. Like I mentioned before, I see that most previous works use the SVM algorithm, which I guess makes sense, since they were trying to find spam-related tweets specifically. That's the work that I saw used that the most. That's mostly it.